Всем привет, раз вас.
Hello everyone. It's my pleasure to see you here. So many of you, it's my pleasure. They say there should be a QR code here for asking questions. And then I'll be able to present you a t-shirt for the best questions. Okay, please do scan the QR code and I'll use the time to sip some water.
Так, ну, наверное, успели, да? Окей. Ага, все, уже включилась презентация, я понял. Так, да, значит, сегодня поговорим про...
Today we'll be talking about CI/CD, attacks and pen tests. Well, not exactly that,
да, потому что ее...
since covering this whole topic within 1 hour would be impossible. But I would highlight integrations today, the integration of CI/CD components, which is my key message today.
Да, значит, Павел Сорокин меня зовут.
This is me. I am Pavel Sorokin. And I'm technical lead in Singleton Security and also in the CyberEd educational establishment. I used to be a pen tester, an AppSec expert. I worked for various companies.
Не помню, 9 лет. Так что смотрел...
I spent about 9 years there. So I considered security from different perspectives, as a defender and as an attacker. And the development infrastructure, or CI/CD, as I like calling it, is my cup of tea. I like dealing with it, and I have a Telegram channel related to CI/CD development infrastructure. Please subscribe.
Так, что еще хотел сказать? Ну, ничего. Значит, о чем доклад?
Okay. What am I going to talk about?
Этим докладом показать, что...
I'd like to show it to you that CI/CD should be considered in its entirety. Well, I know that sometimes they run security audits and pen tests and audits of some components like GitLab or Kubernetes. The way I see it, it is not clever enough. You should have a holistic view. And that's what I'll be talking about today. I hope to convince you.
Значит, CI/CD.
Okay, CI/CD. So we have a lot of integrations between components. That's why we should consider it holistically.
Ну и да, интеграций много.
And there are many integrations. They are sometimes obscure, both for security and for attackers. Well, DevOps just have some add-ons and not informing anyone, and this can cause some unexpected consequences. And this complexity translates into something interesting. That's the way I like it. The more sophisticated it is, the more thrilled I become. So these are my key ideas. I hope I'll convey them to you well enough.
Немножко о том, что такое CI/CD вообще.
Okay, what is CI/CD the way I see it?
Проблемы есть в интеграциях, в первую очередь.
What are the integration issues? So primarily we'll be talking about integration. So we won't be discussing attacks on So we'll be talking about integrations only. So we'll talk about some specific features in components we have found in real systems. But this will be scarce, and then some conclusions. Okay, what is CI/CD the way I see it? I understand we have DevOps, they have their own understanding, they have some kind of own way to segregate CI and CD. But, well, maybe this is not the best term, but it's quite short. I would call it the development infrastructure, and also production and staging and development and so on and so forth, which is too long, isn't it? That's why I'll call it CI/CD.
Ну да. Тут
So here you can see what I've mentioned in writing.
Так, какие компоненты?
What are the components of CI/CD?
У меня тут они тут будут потихонечку появляться. Думаю, многим из вас они будут знакомы.
I think that you recognize at least some of them,
Не очень.
maybe not all of them.
Вот. О некоторых мы сегодня поговорим чуть-чуть
We'll be talking about some of them.
для кликбейта. Если пытаться как систематизировать, то основные компоненты,
The core components of CI/CD
собственно, то есть
are like that. The SCM, GitHub, GitLab, Big Bucket, so repositories, the CI/CD, GitLab, TeamCity, Jenkins, Circle CI, Arco CD, and so on.
для
Then you have the secret manager, the Vault,
runtime,
runtime,
Kubernetes, Docker
Kubernetes, Docker,
и артефакты.
and also artifact repositories, Nexus, Harbor, Artifactory.
Еще может быть много.
And there can be many other things apart from this major set of components any CI/CD will have.
Может, это сейчас поймете дальше, что я также могу к CI/CD отнести все то, что
We can also add there everything related to the security of these components. So if, for instance, Active Directory impacts this, then it will become part of CI/CD.
маленький.
I have an example about it, by the way.
Что еще хотел? Наверное, ничего. Да, значит, собственно, ну, немножко, наверное, оправдаю вообще, зачем этот доклад, да, почему именно CI/CD.
So why CI/CD?
Ну, потому что критично для бизнеса, да. То есть
Because it is business critical.
последствия взлома CI/CD
If they hack CI/CD,
очень большими для
then the consequences can be huge. Like production can stop. For banks and for retailers, this means that their business will stop and they will lose money. They will lose cash. They can also infect artifacts. We can remember SolarWinds with their library, which was spread throughout many clients.
ну, наверное,
And this is really bad for their reputation, which is not a good idea for a business. And data leakage.
продуктовой среды это всегда
So if they breach your
могут быть
production, then it will entail data leakage, and this can cause some fines, and so on and so forth. So we are a technical track, so we will not mention this in detail. One more thing to say is that CI/CD is often overlooked by security, by infrastructure, and pen tests, which is concerning the way I see it, because people are used to breaking the AT, and they think, okay, if you've done it, then you can go deeper. So you start with the AD, but if you have a two-factor system and 90% of the company has MacBooks, then I don't think that's where the story ends.
полностью добраться до продакшена. Так, значит, теперь про интеграции.
Now let's talk about integration.
которое я хочу продемонстрировать только часть.
Now I will show just a small share of integration between components when you analyze the CI/CD security. So this is just a brief set of components, and we can start with a small developer or hacker called Hammer. He has some access to GitHub. It has some runners to do some jobs. So Hammer impacts GitLab, and GitLab impacts runners. So this is these arrows show the security impact.
Что у нас дальше? Дальше появляется
Okay, then we have a vault for keeping our secrets.
нужно получать доступ как-то до.
We need to get access to the secrets in the vault from the runners.
Так, ну и понятно, что раннеры они у нас не про.
We understand that runners are there for a reason. Maybe they collect images or something.
Такая маленькая CI/CD.
So this is a small CI/CD. So and then we have Harbor.
Да, то есть если повлиять как-то на
So if we can impact runners, then we can impact the images which are fed to the harbor. So you can somehow replace them. For instance, if we hack runners, we can also read some secrets from the vault.
Значит, код, который в гите.
The code in the Git, it also impacts the images.
В волте наверняка лежит какой-то
The vault
токен.
most likely has a token to push the harbor.
Иначе как?
So they put it somewhere, right?
Приход.
So if you capture the vault, you capture the harbor or a piece of it.
Еще Kubernetes.
We can also add Kubernetes.
Значит, во-первых, у нас
Okay,
тоже
so
сразу
you also deploy it from runners. Well, runners can also
Harbor и деплоить в
push images to harbor and deploy in Kuber.
Кубере.
So in Kuber, you run the images from the harbor, right? So the security of harbor impacts the security of Kuber. So if we change the harbor images, then a different thing will run in Kuber.
Дальше. Понятно, что из Кубера нужно
It's clear that we need to go from Kuber to Vault. Otherwise, well, production cannot work without secrets, right? Let's add some more. Let's add Ansible here.
Так, ну Ansible у нас наверняка, да, у нас инфраструктура
Well,
хотят.
infrastructure as a code, everybody likes it. It's quick, reliable, convenient, and it's runner-based. So if you capture runners, you will also capture Ansible. And we also have the code somewhere in GitLab. Why do we need Ansible?
Linux серверов.
Ansible will manage your Linux server configuration.
А Kubernetes это у нас Linux сервер.
Okay, Kubernetes is about Linux servers. So if we capture Ansible, it means that we can capture the servers. So maybe in Ansible we'll have the SS key to access these servers. One more thing we forgot about.
Раннеры же тоже выполняются в каких-то образах, да, то есть.
Runners also perform some jobs which are there in containers, so they have images. So Harbor also impacts runners. So we have this
Так,
two-way street.
для
In the vault, we are likely to have secrets for Kuber. Maybe in deploy, maybe we have something to read secrets there. So we must have something in the config. We should keep this in mind too.
Значит, GitLab Runner.
GitLab Runner.
Так, что я хотел сказать-то этой стрелкой? Я хотел сказать следующее, да, что если GitLab Runner небезопасно настроен,
So if GitLab Runner is not securely configured, then Kuber can be breached.
через Runner. Вот, мы захватываем Кубер. Да, тут как бы, чтобы было сложнее, у нас теперь...
So we can capture Kuber. So there are two arrows here between the runner and the Kuber.
А то слишком... Так, да. Ну, еще у нас есть, собственно, наш ГМР-хакер, который...
And we also have the hacker, Homer. He has access to Git. He also has some access to Vault.
Давайте лучше ГМР-разработчик.
Okay, let's call him Homer, the developer. He puts his secrets for his project somewhere, and he must have some rights for developing something, for debugging something, to run jobs or even exec.
И вот такая вот получается картинка.
And this is the picture we have.
Этим всем, что все это...
What I mean is that you should have all this in mind when you analyze security. And these links
Не просто
can be not exactly straightforward. If we get access to a given project in GitLab, then we can read from the vault these secrets, for instance, from a given folder, and so on and so forth. So we can deploy to Kubernetes. And we can read other things from Kubernetes because we have a different set of access settings to Vault there. And let me say it again, this is just a little piece of the CI/CD infrastructure. But still, the number of errors is mind-boggling, isn't it?
Ну да, и стрелки я тут рисовал, конечно, не от балды, все эти стрелки.
And all these errors are there for a reason. They are clear, and I have seen them in real infrastructures we have dealt with. So all of them
Повышению привилегий, может быть, не полному захвату, да, но
caused some privilege elevation. Not a complete capture, but still.
что такое CI/CD, да, давайте немножко поговорим про атакующего, про вот этого самого Гомера.
Okay. A few words about the attacker.
В данном, ну, я рассматриваю атакующего, это разработчика, QA, DevOps, ну, в общем, любой.
Okay. A developer, a DevOps, so anyone who has some rights or credentials in a development infrastructure.
Ну, надо тут сказать, что это... Так, наверное, на следующем слайде, да? Ну ладно, то есть цели у него это, ну, либо повлиять на...
His goal is either to impact the projects in other teams, so he has some rights, for instance, but only related to his projects. But say he wants, say he is interested in going to a CRM or a DBO, but he is not authorized to do this. Maybe he is not in the team. Maybe this is a multi-tenancy infrastructure. So there are many companies running in one infrastructure. So another team can be another company, and it makes things even more complicated. So he either wants control over the whole infrastructure or a part of it. So
взгляд.
he can have this hacker-like perspective.
Что атакующий у нас является
So the attacker is an insider, or he can be broken by some either other hacker. So they can get access through access tokens, through some Jira hosted PDFs, or in some other dumping ground.
Примеры, когда достаточно просто
So sometimes you can have network access without any credentials, but I think this is a rare case.
в докладе, как нарушителя именно вот.
So but I think that here we are focusing on someone with some credentials. So a developer or maybe a friend of developer.
Executor,
So let's talk about runners. Yeah, they are executors, right?
какой CI/CD используется.
Depending on the CI/CD they use. I'll be primarily talking about GitLab because I know it well.
Полностью, ну, довольно сильно, это все будет актуально и для
And this will be also important for other CI/CD systems, not only GitLab based. Okay, runners.
выполняют джобы.
They run jobs.
Как вы понимаете,
But as we know, jobs are run for a reason.
нужны, кто-то их написал,
They have a reason to exist, right? They have a goal.
вот, но это либо сборка и
So they either bring together and push artifacts or images. They can deploy, do provisioning or migrations. And for all of this, you need credentials. This is important for the attackers. So runners have credentials.
ну да, и вот, собственно, они нас интересуют.
This is what we are interested in. So credentials can be with the runners or other jobs run at the runner. So if we can capture a runner, we can deal with the other jobs. The same runner operates, so maybe we can steal credentials there, and they can also elevate privileges. Sometimes you can elevate your privileges if the runner isn't secure enough. Okay, where do we get the credentials from?
Они могут
Well, in GitLab, they can be taken from various places. For instance, GitLab variables. They can also come from different places, like the project group settings, or you can say all instances, for instance, running in GitLab. You can also show this in the pipeline config,
также они могут быть
and they can be also in the pipeline launch parameters and some other places, so they can be in different places.
если пытаться, да, вот вы там анализируете джабу, видите, у них
If you analyze a job, you can see a secret there. Sometimes it's difficult to understand where it came from.
дальше, ой, так, перепрыгнули, runner config, да, вот
Okay, runner config.
важно, да, для вывода.
This is also important for our next steps. Secrets can be held at the runner,
Все проекты в рамках какого-нибудь
and this can be convenient if we have all the projects run by a team, or all the GitLab projects, for instance. They all have to be deployed in Kuber.
то, возможно, мы захотим сделать
Maybe we want a shared runner for this secret for the deployers to be held. So it is shared, it's available to all GitLab projects, and we can use it. So you can bring them to the environment variable, you can have a secret there, and this variable will go to all the jobs starting from this runner. Or, as you can see to the right, it can be done as a file.
конфиг, который подкладывается
The Kuber config, which goes to the job. So you can see the slashes used for this.
ну, из волта, да, ну,
And you can also use the vault to get it.
потому что
Well, to read some secrets in the vault, you need to authenticate there, and to authenticate there, you need some credentials.
там хорошо, что в GitLab есть
But in GitLab, we have CI job JWT, which is a standard variable generated by GitLab. This way you can authenticate, and then Vault will understand which project you represent.
Так, и типы раннеров, да?
The types of runners:
Shell, Docker, Kubernetes.
Shell, Docker, and Kubernetes. This is not exhaustive. In GitLab, they have about 15 types. I will not go into this detail.
Что я хотел? Да, значит, да, я хотел, почему мы, собственно, про раннеры так подробно.
Why are we talking about runners?
Как раз все эти интеграции.
We have all these integrations implemented on runners.
Потому что это очень удобное место.
Because this is a really convenient place for this. So DevOps, for instance, they like developing jobs for runners. And that's why you should understand them well to analyze them.
Раннеры.
Okay, shell runners.
Это доступ.
But okay, let's talk about access to runners. Runners can be shared, so they're available to all projects and all users on an instance. They can be group or project specific.
То есть там все проекты в рамках группы.
So the group specific means that all the projects in the group can use the runner and all the secrets this runner has.
Ну, давайте про shell раннеры. Значит,
Let's talk about shell runners.
выполняются от имени.
Jobs of these runners are implemented on behalf of one user. So he can read the code of the jobs. So when the jobs are run, they are stored in a folder. You can read the code, you can change the code, you can change the artifacts. So you can see a library and you can quickly replace it.
Никто так не.
Well, I don't think anybody does it because it's more easy to steal secrets from some other jobs. So the network, the environment variables, so you can get it from the proc, and this way you can rewrite the image or do other things. Artifacts can also be
В файлах, да, потому что у нас
in the files, since all the jobs are performed on one virtual machine or one server, and if they have some traces left somewhere, they will be there until deleted by somebody else. It can be the configs of Docker, Kuber, SH keys, and so on. And you have credentials there, naturally. Here is a scheme of the things we're talking about. The attacker has access to GitLab. It creates a job there. It is performed on a shell runner. So the attacker can manage the Java code. It investigates the runner, finds the secrets. The group job finds an SH and uses it to get access to the VM.
значит, докер-раннеры. Значит, докер
Okay, Docker runners.
выполняются в контейнере.
Every job is run in its own Docker container.
Себе так.
This configuration is secure
Вот, ну, значит,
if we forget about exploits. But as it often happens in the CI/CD world,
контейнеры
containers like that can be forwarded to Docker sockets. And in this case,
мощь докера, да,
we can use
с докер.
Dockers to interact with the host daemon Docker.
Смотрите,
So we can have a look at the Docker VS, exec, and so on, and some other neighboring jobs, and we can also make it to the host. So this is the shortest command to launch a process which looks almost exactly like the host root, and you can use it to look at all the jobs. Here is another example. This is an attack. We use Docker runner to call Docker daemon, we steal the secret from the good job to push an image to the registry. So we push there an image and something we bring together, and we push it with the credentials we have stolen, and so then this image goes to the prod. So we have captured prod or a part of it. So the service
Креды от пуша, которого мы украли. Для пуша.
we stole the credentials for. And Kubernetes, so here every job is in its own code, in its own pod. It is secure by default, but we have a DINT. Well, that's another issue. If we need a Docker, so then here we have a DINT. And if we have a DINT, then we have a privileged. And if we have a privileged, then we can go to the daemon.
Ноды.
So as an example, we just mount the node file system, and that's it. And then you can do anything else. So just write in the root. You can actually devise a dozen or more versions of options of how to get to the node and run commands there.
Если у нас есть такая возможность, мы уже
So yeah, if we have this opportunity,
выбраться на нод.
we can get to the node and then develop the attack against the Kubernetes, and then after that penetrate the system as a whole. Okay, by the way,
Доступа без кредов.
regarding the credential-less access, the only example I'll show is right here. This is the code from the GitLab documentation how to do DINT. You run the service. The service is a sidecar container as part of production. It starts this daemon. It requires this privileged root. And here this thing is of interest. If you run the job this way, then the Docker, this Docker inside the sidecar, will be run on the IP of the pod. So if we have access to the Kubernetes, we can just use this address and get
Привилегированный доступ.
immediately privileged node access.
Так что да,
So
сканировать.
you can periodically scan the Kubernetes network and look for 2375 if we have direct access there.
Значит, да, тут вот чуть-чуть с другой стороны.
This is a look from a little bit different perspective. The problem here is that Docker is a runtime and build environment at the same time. As a rule, it's the build environment that you need, and runtime only creates risks. But everybody's got used to Docker, even though there are similar environments which don't have runtime and only have the build environment. But if you do use Docker, I'm just giving a QR code to my presentation at Beacon, where we share our approach to protect Docker Runner. So you can take a look if you're interested. Now, a piece of advice about Runner for the attackers. First, you have to remember that all runners are different. Different credentials can be used at different runners. Runners can run different jobs. The more different runners you have access to, the higher the
Да.
probability that you'll find something useful. Coming back to GitLab, to run a job, you need to have a developer or higher rights.
И, соответственно,
Then we can place YAML and have the right to run our job. If we have access to some projects, then perhaps there are some other runners that have not been accessible to us. And the third thing, that the job you need may not arrive in the first batch. So, for instance, they were looking, Ansible started running with SSH keys.
Нужно подождать.
So, you need to wait a bit to find something interesting. Now we've talked about Rana. Let's talk about the integration with the Vault. Firstly, how this integration is built. It's not quite obvious. In GitLab, we have the CI job JWT that I mentioned earlier. I am showing a small excerpt from it. There's this thing called project path. And in the Vault, we have policy. So you configure a kind of policy for GitLab that, of course, is just one other way, but its job is to take this project path from a JWT that comes from the job that you can substitute. So if we have this, then this project will have access to all the secrets stored in secret data developed front end main site. It's a hierarchic structure which is copied effectively from GitLab to Vault. This is one of the ways it can be done.
Так. Вот. А в Кубере у нас...
And in Kubernetes, it works a bit differently.
Нет иерархической структуры.
There is no hierarchic structure there. We only have namespace there. So this is again an example. And I must say that there are service accounts, and you substitute a JWT from the service account to the pods, and they can be used to get authenticated in the Vault. And this is the namespace that offers you access. But as you see, we're only going to get one level because there's no nesting in Kubernetes. As to the secrets, they can be pushed from Vault to the Kubernetes. So to be written in the namespaces we require. It's also one of the options, and in this case we don't need any JWTs. So the secrets get to Kubernetes themselves. But it doesn't matter. In any way they get to some namespace. So a Vault in GitLab supports a multi-level structure of secrets, whereas Kubernetes doesn't. So then this is kind of a mismatch. So if we need to provide access to the same secrets from both the GitLab and Kubernetes, and why it may be needed, I'll mention a little bit later. So we're running into a problem that you also have to understand. So by the token of the service account, from one pod related to some project, you can get access to the secrets of all other services that are running in the same namespace. All the neighboring ones. And if we use mechanics 2, that's secrets are pushed from the Vault to the Kubernetes. Then when jobs are created, when the pod is created, we can refer to somebody else's secret that's stored in this secret and get access to it. So it's quite probable, or there is a probability, that a developer of one project will gain access to the secrets of the neighboring project, not directly, but via Kubernetes.
Вот. А с GitLab у нас...
And is everything fine with GitLab?
Так. Ну, практически, да. То есть у нас...
Well, effectively, yes. In GitLab, we have a problem with environments. GitLab doesn't know whether it's production or not production.
И при этом... Ну,
And this being said, you also have to understand that in jobs, you will almost certainly need access to production secrets, for instance, for migration. So you just need this kind of access. So if there are relevant rights in the project, you can also get access to the production secrets from a GitLab job, just having the access of a rank-and-file developer. It is possible. Of course, it all depends on the specific settings, but this looks like a typical scenario. Yeah. So what is this Kubernetes token? It's always stored in this path. Its function is to interact with kubeAPI, but it also can be used as a kind of a service passport in order to introduce itself to other systems, for instance, to the vault, and that's how it's done. And for an attacker, it may be of interest to collect these tokens, because, yeah, we're talking about integration, and we may be interested in collecting these tokens from the viewpoint of integration, not really to get access to Kuba API, but to grab secrets in the vault and to go on behalf of some secrets. So it's clear that Kubernetes offers a lot of rights. I've just listed a couple of them. Exec. So, for instance, we can sign up as an exec in some namespace. For instance, so we read some token in the picture, and from it get to the vault, getting other people's secrets. Or if we can create pods, then we can also create pods, and Kubernetes will itself substitute secrets that we will be using. Actually, what I had the time to share, I have now a few fun facts from actual experience. The first thing is about the pre-built script. So what's a pre-built script? This is a thing in GitLab that it's set up in the runner config. You remember I showed you the runner config where secrets were held. So developers have no impact on them. It's impacted by the GitLab runner. And then there's this build script that will be run always when the job is run. And the idea is to place some protections there, such as integrity, control, and other things. So if it doesn't pass, we just drop it. The idea is good, but it doesn't always work. I have a whole of 3 ways to bypass this protection, depending on how strong, how much people were thinking about the protection. Firstly, you can bypass after script. After script is required so that some post-error artifact could be created. So it's run always, even if the pre-built script failed. So you don't need to do anything actually about that. You just write out the script and grab the secrets, and it will work. If we
проверяют, что автор скрипта нет каким-то образом.
if they somehow check that AutoScript is not there before launch, or in the process as such, in the pre-built process, they check that AutoScript is not there, what they do? They can replace the image. And this is the way they do. The pre-built script is run in the container, and it's just an image. And what's an image? It means that we can substitute something. For instance, upget. For instance, we can start the pre-built script with get update. Okay, then we substitute river shell for get, and when the build script starts, it just throws us river shell, and that's it. This is the image manipulation. You can protect yourself from that using the parameter runner allowed image. And the third thing is about services. So if we have allowed images, then we can services, the sidecar container that's run next to our job. So the pre-built script will not run there. So it can drop the main job, but the sidecar will start anyway, and there will be the same NVs and runner secrets that are contained in the main container. So we just configure a river shell sidecar, and you can get protected with allowed services. And one more point. Kyverno. It's an engine. It's a policy engine. Perhaps you're aware of it. Used to protect yourselves from a lot of things, including bad pod. So from running privileged containers. So it turned out that if you install Kyverno by default, not changing anything there, so resource filters are set up where all Kyverno checks are blocked for the following namespaces. Well, I can understand kube system, but I think if you take kube public, it's actually a big question of why it is needed. So if the protection against these blockings are installed, we can still access QPublic. And in conclusion, a very short example about Active Directory, the CI/CD case, where users in the custom field have SSH keys indicated for the custom users in AD. So they don't get there immediately, but directly, but rather through some job. So once in every period of time, according to the schedule, the job is run, and we can, if we can get access to this job, we can find a secret related to some custom field, and configure a new public key, for instance, for a server admin, and then we can use it to get the admin in the Kubernetes. So something like that. All I have shared with you was to show that the integrations can be different, diverse, and sometimes very complicated, and you'll need to take that into account. Yes, and reminding you that CI/CD should be analyzed as a whole, not in pieces. So it would be strange if you just do it piecemeal, because you need to have a general picture. And yes, I'm hoping that I've shown you that CI/CD is exciting, and it's exciting to try and find your way with it. So that's it. Thank you. So please subscribe to my channel. And I'm supposed to have questions somewhere here. Okay, questions. Quite a lot of them, actually. So, reading question: how to track and counteract the attacker in slide 56. Look, it's going to take me some time even to get back. 56, is it where there was the schematic? Okay, while I'm scanning. apart from scanning the source code, what's the best tool to explore vulnerabilities? And by the way, I won't be able to tell you anything useful about tools. I'm not really a big lover of tools. I love to do things manually, finding the ways to understand how tools work. So maybe I'm not going to answer this question. Security and CI/CD and open source projects should be provided just like in the enterprise segment. Or are there any differences of principle in open source projects? Look, perhaps I won't be able to answer it off the cuff. One needs to think. I haven't thought about it. So I'll allow myself not to answer this question. Oh gosh, 3 questions from Peter. Which unique challenges arise in CI/CD in cloud environments as compared to on-premises environments? So look, the title sounds like a PhD thesis title. Okay. Well, in the cloud, you need to consider the specificity of the cloud, perhaps only this, because what's in Azure, what's in other architectures. But on-premises infrastructure are different in that they're all different. Even the Kubernetes is different, and all the IDE environment is for sure different. So I think I still have some time for questions. How to forestall and analyze the actions of the attacker from the blue team. Okay. Look, maybe I'm not exactly blue team, but I'm certainly not a SOC. But perhaps I can offer some ideas for consideration. The attacker would want to use River Shell always, so you can find, we can try and find them from the host, because you can see all the containers from the host. Any River Shell will be able to see it, and any IDR mechanisms should be able to work to identify things that look suspicious. Also, Kubernetes have some specific monitoring. For instance, outlier detection, and it works quite well on Kube because you can take a profile from every container. Well, I'm just not a deep specialist to give you a good answer to this question. So I gave some ideas, but obviously it's not exhaustive. Docker analogs for building have a lot of drawbacks regarding vulnerabilities. Well, I don't remember anything about vulnerabilities, but what kind of vulnerabilities are important at the build stage? I mean, the runtime stage is different. How realistic is a scenario to get the runner substituted on the fly? Well, it's quite real. It's quite realistic. If you make an effort and write some code that will substitute something at the right moment, or pause some process if we have root access, it looks quite realistic. But as I've said, it would probably be easier to steal the credentials and do the replacement, do the substitution later. So the job has run, and right after that we substitute something of our own. How do you protect the variables in CI/CD? So we can replace the vault address by our own address. It looks like CI job GWT is already deprecated. There should be some GWT. Maybe it's called differently. I don't really remember that it's been deprecated. Well, if we have the right, the permission to change the vault adder variable,
поменяется,
So nothing will change. It just gets a bit complicated. So I don't know.
Так, что у меня там еще немножко
So
времени?
what else? Do I still have a few minutes? All right. So I've run to the end. So back to the first question: how to stand in the way of a hacker at every step in this schematic? Well, I don't know. Well, I've already spoken about the Kubernetes as to runners. You know, runners are Linux things. You can also monitor them, take a look at their behavior. Well, I don't know. I don't know what to say.
Не моя специфика.
Well, it's monitoring is not really my cup of tea.
Компрометации.
Most frequently, which compromising methods are used?
Говорил, да, что
Is social engineering used broadly? Well, I've already said that you don't really need people. You can get tokens from GitLab. It's a good way. People found tokens on Windows shares, for instance. And then once you find some, you can access GitLab with some credentials, some permissions. Creating a separate CI/CD instance in the deployment prod is about creating some additional problems. Well, if you don't allow people there, it may not be bad. If you have some automatic deployment to production by some button somewhere on the side. But then, of course, every deployment should be secure with a certain registry and so on.